Hello once again, class, and welcome to another mock lecture. Today we're going to be talking about unit conversion. And we're going to start off with a little bit of a question here. How tall are you in miles? If you know your height in feet or inches, you can actually figure out what your height is going to be in miles. You just need to know what's called the correct conversion ratio. And that's really what today is about, this unit conversion stuff. In general, a conversion ratio is a ratio that sets up an equivalency between two different units. So I put 4 on the screen here. 1 feet is the same as 12 inches distance-wise. 8 fluid ounces is the same as 1 cup. 1 yard is the same as 3 feet. And whatever that number is, I'm going to go with 1,825,200,000,000 nanometers is 1 nautical mile. They're the same thing, same distance. The purpose of these things is so that we can change the unit of measure of something without actually changing the physical amount, right? In the most examples that we just showed you, without changing the actual distance, like 12 inches is the same, right, as 1 foot. So say we wanted to turn 3 feet into inches, you could multiply by the conversion ratio, right, which is 12 inches per feet. You'd get the feet units to cancel. And what you're left with is 3 times 12 just in inches, right? So 3 times 12 is going to be 36, so 3 feet is the same as 36 inches. Now, why does this work? Why are we just allowed to do this, right? We're multiplying by something that's seemingly not the number 1, but that's the whole thing, right? That's why these things are really neat and really useful. We're not changing the actual distance. You can think about 12 inches over 1 foot as 12 inches over 12 inches. And when you divide something with itself, that's the number 1. So we are technically multiplying by the number 1, which is not changing the integrity of the number that we're looking at. It's just converting it into an equivalent distance in a different unit. That's the whole purpose of conversion ratios. This process, by the way, is called dimensional analysis. We want to change if you want to change the unit of measure for something, you have to perform a dimensional analysis process on it. And in general, dimensional analysis is if you have some number of units, right, and you want some different units, you have to multiply by the corresponding conversion ratio between those two units. And then you'd end up with the number of units that you want. So here I have number of units you have multiplied by number of units you want divided by number of units you have. The number of units that you have, right, or the units that you have, I should say, cancel, and you're just going to be left, after you do whatever this multiplication is, you're going to be left with the number of units that you want in this particular case. And you can do this more than once. Like let's say you start with the number of units you have. You don't know the exact direct conversion ratio for the number of units you have to get to the number of units that you want, but you know these intermediary steps. Like you have units you kind of want, and then over the units that you have, right? So you have like this middle conversion factor here. But then you also know the units that you want versus the units you kind of want, right? So things cancel this way. First, they cancel this way, so then you have units you kind of want, then they cancel this way, so then you end up with units that you actually want, right? So you can chain a whole bunch of these things together in order to get whatever your numerator and denominator units are supposed to be in the problem that you're doing. So how tall are you in miles? Well, we can use me as an example. I'm exactly 6 feet tall. Technically, I'm 5 feet 11 3/4 of an inch, but if I'm wearing shoes, then I'm 6 feet tall. And if I'm going to use the conversion factor, right, for miles to feet, that's 1 mile is 5,280 feet. The question is, how am I supposed to orient this fraction? Should it be mile on the top and 5,280 feet on the bottom? Or should it be 5,280 feet on the top and 1 mile on the bottom? Well, remember that what I want is I want my height in miles. So I have feet. I want miles in the numerator because I need the feet to cancel. So I'm actually going to use this one. So 6 feet times 1 mile over 5,280 feet. The feet units cancel, so I end up with 6 over 5,280. Because remember, this is like 6 over 1, and you just multiply fractions straight across. And that's how we're getting this. Notice the only unit of measure now is just miles, so that's where I got that. And I used a calculator, and I got 0.0011364 miles tall. That's how many miles tall I am. With shoes, I guess. All right, example number 1. Suppose you're traveling in a car with your dog at 65 miles per hour. How many feet will you cover in 25 seconds? Now, I'm actually going to do this part last. The 25-second part, that can be last. Right now, I just want to figure out, we have a speed in miles per hour. So the ratio is miles in the numerator, hour in the denominator, and I want to end at feet per second. So we're going to have to not only convert the miles distance into feet, we're going to also have to convert the hours unit into seconds. All right, so let's see how this would work. And I'm just going to find our speed in feet per second first, and then I'll multiply that by 25 since we know we're traveling for 25 seconds. So first, I'm going to go ahead and work on the time unit. So I've got 1 hour. I want to turn that into minutes first, so I need to do the conversion. There's 1 hour for 60 minutes. I put the hours in the numerator so that it cancels with the hours in the denominator, and now my unit of measure is going to be in minutes. Okay, so now I've got 65 miles in 60 minutes as my speed in minutes. I want seconds, so I got to do another one, right? There's 1 minute that comprise 60 seconds, right? Or 60 seconds comprise a minute. Notice again, minute in the numerator because I'm trying to cancel the unit in the denominator. Second is now my desired denominator because I want feet per second. So second needs to be in my denominator. Okay, so that takes care of the time unit. To take care of the distance unit, we already actually talked about this. There's 5,280 miles. No, there's not. There's 5,280 feet in 1 mile. And so I just need to multiply by 5,280 over 1 mile. And that's exactly what I did here. So that the miles unit, miles is in the numerator. I want to cancel that unit, so I end up with feet in the numerator. So the miles here canceled. Right, canceled with this one. So now, finally, I've just got feet per second. Those are the only things that we have not canceled out, crossed out in this situation. And so we get 95.33 feet per 1 second. Okay, and you're just going to have to trust me because I just use a calculator. Although you should verify, try it out. Do 65 times 5,280, divide that by 3,600 because that's what 60 times 60 is. And you should get this. Okay, now, we're doing this for 25 seconds, so then I multiplied, and this is actually kind of cool. Notice I'm multiplying a speed, a feet per second, by a number of seconds, and when you do that, the seconds unit cancels. So you just get feet as your unit of measure, which makes sense, right? How many feet will you travel in 25 seconds? This many feet, right? It's not a speed that we're getting, it's just the distance. But again, I just typed this into my calculator, 95.33 times 25 was 2,383.33333333 forever feet. 2,383 and 1/3 of a foot is how far we would travel. All right, example number 2. Suppose you have a 4 by 3 by 2 inch glass container and you want to buy a bioluminescent fluid to fill it with, but it's only sold in cubic centimeters. So if you multiply 4 by 3 by 2, you're going to get cubic inches. But this liquid is only sold in cubic centimeters. So first we need to figure out what is the volume. Well, first, the only thing we need to figure out in this case is what is the volume of your container in cubic centimeters. Here's our container, right? 4 by 3 by 2, 4 inches wide, 3 inches long, 2 inches tall. The dimensions actually don't really matter. It's this volume is volume. Volume is actually this. Length times width times height. And again, if we do that right now, you're going to get 24 inches cubed because 4 times 3 times 2 is all in inches, and inches times inches times inches is a cubic inch. So to figure this out, what we need to do is know the conversion for how many centimeters there are in an inch. And in fact, that ratio is 2.54 centimeters per 1 inch. And notice that I've oriented this in the correct way already. I did not have this flipped. I want to cancel the inches. But the thing is, this unit of measure isn't inches. It's cubic inches, right? So right now, if I do this, I'm just going to get 24 inches squared centimeters, which isn't a unit of measure that's worth anything, right? We want to convert it into just one unit of measure, so cubic centimeters. To do that, I need to cube. Oh, and by the way, I also put this is over 1, right? It doesn't have a denominator. This is not a conversion factor. This is just 24 inches cubed, but we're going to multiply straight across to figure out what's going on. But again, the issue is still here. This is not the same unit as this. So we need to fix that by cubing the conversion ratio, right? When you cube a fraction, as it turns out, you're just cubing both the numerator and denominator independently. And if you cube the unit centimeter, you get centimeters cubed. And if you cube the unit inches, you get cubic inches. So 2.54 cubed is 16.387. And now I've got centimeters cubed per inches cubed. So it's kind of like a new conversion factor. This is your centimeters cubed to inches cubed conversion factor. So I'm going to go ahead and now do the multiplication, because now we will get the inches cubed to cancel. And we get 393.288 cubic centimeters. And that is it. Okay, just those two quick examples talking about unit conversions, conversion ratio, and dimensional analysis. Hopefully you guys learned something. If you have any questions, please leave a comment below or shoot me an email. Thanks a ton for watching, and I'll see you in the next one.